हैव टॉक्ड अबाउट यूएन ग्रुप के बारे में मैंने बताया था, जिसमें यूएन इज़ अ नॉन अबेलियन ग्रुप, ऑल्दो बट इन सम केसेस इट इज़ ऑल्सो अबेलियन ग्रुप्स व्हेन if you take an is prime. So that's all UN, but now we will consider from the example number 12. Yes, so we just take we just take so example number 12. In this case, yes, this one, the set 0 1 2 3. This is the set 0 1 2 3 is not a group under multiplication modulo 4. Why it is not a group? Because 1 and 3 has inverses. 1 and 3. 1, what is the inverse of 1? Inverse of 1 is again 1, because 1 into 1 is 1 mod 4, right? And if you take 3, then it is again 3 into 3, which is 9, equal congruent to 1 mod 4. So that's case. So inverse of 3 exists and 1 exists, but you find that 0 and 2 do not have inverses, so it is not a group, because 0 is not congruent to 1 mod 4 in any case, and 2 is not congruent to 1 mod 4. 2 into b is not congruent to 1 mod 4 for any b. So it is all clear. Yes. So now we just see the example number 13. Set of integers under subtraction. Set of integers under subtraction is not a group, since operation is not associative. Mind this, that operation is not associative here. So if you take subtraction in integers, this subtraction, like if you consider a minus b minus c, then it may not be a minus b minus c. Yes, so this is the whole case. So let's consider example number 14 now. So this will not form a group. Now let's see example number 14. So we just take the set of complex numbers, the complex number c plus a plus bi, where ab belongs to r, such that I square is minus 1. Yes, so this is the set of complex numbers. This is hopefully equals to, this is equals to here, this is equal to, yes. So it forms a group, right? How it forms a group? You take any two elements of this set, a plus bi plus c plus di, then it is again a plus c b plus di. So in this example, a plus c is going in real line and b plus d also going in real line, because if you take a from real and b real, then their sum is also real. Inverse of a plus bi is also you can take minus a minus bi. Yes, so if a plus bi plus c plus di is 0, then here you can find that c is minus a and d is minus b. So non-zero complex numbers are group under operation. So this is c plus. C plus is a group under addition. So this is all c plus group under addition. So and there is another group which is called as c star dot. So there is a group which is called c star dot, then it is a group under multiplication. So it is a group. So let's consider this. See what happens is that when you consider c star dot inverse, non-zero complex numbers are grouped under operation a plus bi c plus di is this. So inverse of a plus bi is here is 1 upon a plus bi, and you can rationalize this. You know, in rationalization you must multiply by a minus bi and divide by a minus pi, then you get this whole thing. So this is where you can find the inverse. This is basically the inverse of a plus ib. This is inverse. I just write in a very bad handwriting, because I don't have anything like iPads. So this is all where 1 plus 1 upon a plus bi can be expressed like this, and all are real number because they are non-zero. Denominator is non-zero. So this is c star dot is a group. And what is the identity of c star dot? What is the identity? It is 1. So you can find inverse, you can just perform every operation. So yes, this forms a group. Now yes, consider another group which is a very important group. This is a group for all integers and the set of complex nth roots of unity. Like in complex numbers you studied. What you studied in complex numbers, in real line, if you take cube root of unity, then how can you express? You express in the form of complex numbers, right? So like nth root of unity. So what is the nth root of unity here? You can express this set like this. If you have any doubt, then you can ask. Although it forms a group under multiplication, so you can easily prove that it is a group. So what is the notion behind this? That you can consider the set. I will give you hint. 1 x square and up to x की power n minus 1. Yes, because x की power n is going to be 1, right? Nth root of unity. So you just consider these powers and prove that this forms a group under multiplication. So you just remind the notion, you just remind the statement. There is the proof is not necessary here. Set of complex nth roots of unity forms a group under multiplication. So this is all easy way. Now we just talk about, yes, this is a very important group. Rn में कैसे elements आ रहे हैं? Tuples आ रहे हैं, n tuples where a1 a2 an are from R. These are from real line, and if you add these two n tuples, then you will get corresponding component wise addition. Then it forms a group. What is the identity? 0 0 0. If you take all ai's as 0. What is the associativity? You can check. Commutativity is also an abelian group. You can check. Identity you can check 0, है ना? Closeness भी, and inverse is minus a1 minus a2 and minus an, because you added to a1 a2 an, then it is again 0. So it's all easy concept. Yes, you can try example 17. If you have any doubt, then you can comment. Yes, it is basically translation group but not so important, so I am skipping it. Yes, so yes, so we just consider another example, which is example number 18. So set of all 2 cross 2 matrices with determinant 1 with entries from Q, R, C or Z, P is a non-abelian group under matrix multiplication. So here the determinant of all the matrices is going to be 1. So this group is called special linear group. So like in GLNR where you take determinant non-zero, but here you are precisely taking the determinant to be 1. So what happens? It is SL2F. GL2F we have talked about, but it is SL2F. So what is the inverse of ABCD? Because determinant is 1, the inverse is like this. You can verify it, and yes, so illustrate Z SL2 comma Z5. Then we consider the element A. Then determinant of A mod 5 is going to be 1. Yes. So inverse of A is, you can easily calculate from the formulas. It's all easy, and you can show that it is a group. Now we move towards another group, which is where we talked about the inverses. Yes. You can check, you can find the inverse. You can see example 19 yourself. Example 20. The set n is a group under 1 to n minus 1 under multiplication modulo n if and only if n is prime. So this is a particular case of un where n is prime, right? It is a group under multiplication, and if n is prime, then you can prove that this is a group. सेट ऑफ ऑल सिमेट्रिक, बिकॉज UN में कैसे आएंगे? GCD जिनका इनके साथ 1 है, HCF जिनका इनके साथ 1 है, बिकॉज n इज़ अ प्राइम. सो 1 2 का और n-1 तक का सबका GCD n के साथ क्या होगा? 1. HCF क्या होगा? 1. So all elements are coming in the set. Set of all symmetries, you just see, this is not a very good example. I just skip it. Yeah, it is not important. So there is a table. There is a table as shown. Then you can easily see that in this table you can easily see that there are some more important groups that we have discussed earlier. So you can easily revise these groups from this table, and if you have any doubt you can comment. Again I say, Now we just focus on some elementary. This is very important section, so I want to discuss this first. These are the elementary properties of groups. So what are the some properties that you must know for the groups? Yes, so कुछ properties है जिनका बहुत ही basic तरीके से use होगा, and they are very important in turning the questions and doing the questions in groups. So you must know them, know their proofs also under in spite of a statement के अलावा भी आपको proofs करने हैं. So just study. Every group has an identity. Yes, it is true. Every group has an identity. Every group has an inverse. So what can you say? If a group has an identity, then it is only one or two or three. What can you say? This then will be established by the theorem that identity of group is unique. What can you say about inverse? Inverse कितने मिलने वाले हैं आपको? ए बी इक्वल वन, ए सी इक्वल वन, ए डी इक्वल वन, ऐसे तीन मिल सकते हैं आपको? नो. सो द आंसर इज देयर इज ओनली वन इनवर्स एंड द इनवर्स इज यूनिक. सो वी जस्ट फोकस ऑन दिस more. So now we just focus on uniqueness of identity. Yes, so although I have discussed in the last video, but yes, we will do from this book also. What is the uniqueness of identity? In group there is only one आइडेंटिटी एलिमेंट, राइट. सो आप कोई भी ग्रुप ले लीजिए, उनमें आपको क्या मिलने वाला है? एक ही आइडेंटिटी एलिमेंट. सपोज ई एंड ई डैश आर आइडेंटिटीज ऑफ जी, देन ए इज ए एंड ई डैश ए इज ए फॉर ऑल इन जी. ये तो क्लियर है. आप उसकी मल्टीप्लाई ए से करेंगे तो ए आएगा, और ई डैश की भी ए से करेंगे तो ए आएगा, राइट. सो द चॉइसेस ऑफ ए इक्वल ई डैश एंड इक्वल, बिकॉज ये सभी ए के लिए ट्रू है. ए इज ए, एंड सो इफ यू टेक ए टू बी ई डैश इन फर्स्ट इक्वेशन प्लाइज ए इक्वल टू ई डैश, then what happens is yes. So what is the identity? Yeah, a is a for all a in G and e dash a is a for all a in G. Then if you take a equal e dash in first equation, you just take this in first, and a equal e in second equation. Then what you got? E dash e is equal to e dash, and yeah, this one e dash e equals to e. So thus e and e dash are both equal to e dash e, and so equal to each other. So again, this is a very important proof, but it's quite easy. Because of this theorem, we may ambiguously speak of identity and denote it by e. So yes, we can, because of this theorem, we can always speak identity as, we can always represent identity as e, because it is unique, right? Now there is a cancellation law. There is a cancellation law which in a group G, the right and left cancellation holds. That is, if B equals CA, it implies B equals C, and AB equal AC implies B equals C. तो लेफ्ट कैंसिलेशन लो भी होल्ड करता है ग्रुप में, और राइट कैंसिलेशन लो भी होल्ड करता है ग्रुप में. सो ये भी बहुत इम्पोर्टेंट है प्रूफ इसका. जो लेट्स सी दिस. या so we just go back. Suppose BA equals CA. BA equals CA is given to you, and A dash be the inverse of A. Then you multiply A dash on the both sides, right? So what do you get? Associativity yields what associativity yields? You can use associativity and you come to conclude, because A dash is the inverse of A, then A dash is identity. It is replaced by E, B, C, because identity multiplied by any element is again B and C. So B equals C. Similarly, one can prove that AB equal AC implies B equals C by multiplying by A dash on the left. So it is again a very good proof. This is cancellation law. So you can basically क्या है कि आपको AB equal AC लेना है, तो आपने A इन्वर्स से मल्टीप्लाई कर दिया दोनों तरफ. एसोसिएटिविटी का यूज़ करके इन्वर्स से आइडेंटिटी हो जाने वाला है, तो B equal C हो गया. That's it. So this is the whole cancellation law. So I wind up this session for today on this cancellation law. So from next video onwards, I will be starting new topics where I will be proving uniqueness of inverses and come to another important points. Right, so stay updated, and don't forget to subscribe the channel. And if you have any doubts regarding this video, you can comment on the comment section box, and I also urge you to do the exercises behind the textbook. Yes, exercises of this chapter, and read the theory carefully. And if you have any doubts, then you can comment. Thank you so much. All the best. Bye.